Steve Sakalis, the Department of Physical and Earth Sciences, geography professor there. And it's my great pleasure to introduce one of our outstanding undergraduate geography students, Payten Samuels, one of our GTU members, an International Geographic Honor Society, and she's also very active in the community, doing trail mapping at the state park, at Cheehaw State Park. And another thing that Payten's been doing for us is she's a certified water quality monitor for chemistry and for bacteria. So we've been collecting data for the past year as the Geography Club, and Payten's been very active in this group and is going to present to you today some of our findings from a complete year's worth of data. So without further ado, Payten.
Thank you. Good morning. My name is Payten Samuels, and today I will be presenting the research that I've been working on with Dr. Sakalis for the past year. We have been monitoring the health of 3 local streams in Jacksonville.
Is it turned on? We might have turned everything off yesterday, sorry. Oh, here we go.
So I would like to begin by explaining or introducing you to the Alabama Water Watch. Alabama Water Watch is a nonprofit organization with a university-based program out of Auburn. It consists of citizen monitoring groups. They test the water quality of all of the major river basins in Alabama. They are approved by the Environmental Protection Agency and the Alabama Department of Environmental Management. They started in 1992, and by 2011 they had 65,000 records from 2,100 sites on 800 water bodies from 260 plus groups. Their mission is to improve water quality and policy through citizen monitoring and action. And in 2013, Mrs. Patolo of the Geography Department discovered Alabama Water Watch. And when she did this, she noticed that the locations for Jacksonville had been neglected over the past few years. She mentioned this to a few students, and a lot of them were interested in becoming qualified to test water quality. So Ms. Hutchinson from the biology department assisted us in training workshops, which led to the creation of the Jacksonville River Monitors. The Jacksonville River Monitors is a group of about 40 plus students who are all trained in chemistry monitoring and bacteriological water quality monitoring. We've collected data monthly since the January of 2014. The monthly testing is required to keep a good track of the water quality because it can change daily, so they prefer that you test it at least once a month, preferably around the same time each month. After the formation of the Jacksonville River Monitors, we decided on 3 locations within Jacksonville. These 3 locations are Ladiga, Germania, and Alabama 204. The locations were chosen due to their significance to the community of Jacksonville. The Ladiga and Germania locations are they're popular recreation areas, and the Alabama 204 location was interesting due to its proximity to the water quality treatment facility. The Ladiga location is near the first bridge where the pavilion used to be, and the Germania location is within the stream that goes to the park. The Alabama 204 location is under the bridge adjacent to Cooter Browns. Here is a map of our locations. This is showing Calhoun County and all of the rivers within it. In it you can see our 3 locations, which are all within the Tallahatchie Creek watershed. And after we chose the locations, we started collecting data. The data was collected using Lamont kits, which are suggested by the Alabama Water Watch. They were provided by Ms. Patolo, and they are equipped with the essential chemicals and supplies for testing water quality. The use of the Lamont kits is also approved by ADEM and the EPA. And this brings me to our research question. During the year 2014, which locations were outside of the established safe zones for the following variables: pH, hardness, dissolved oxygen, and alkalinity. I'll now go on to explain what these variables are and the results that we found on these variables. pH is the relative measure of hydrogen ion concentration within the water. So basically, the pH is determining the acidity of a water body. On a scale of 0 to 14, anything below 7 is considered acidic, and anything above 7 is considered basic or alkaline. The optimal range is 6 to 8.5, and our results for all three locations are between 7 and 8 throughout the year, so this is really great. Next is the hardness. Hardness is a measurement of the concentration of calcium and magnesium ions within the water. Soft water is between 0 and 60 milligrams per liter, and hard water is any amount above 60. Our data showed all three locations had relatively hard water all year, and this is not necessarily a problem, yet the multiple instances of results above 120 milligrams per liter at the Ladiga and 204 sites is concerning, because this could have potential negative effects on the fish in those locations. Next is the dissolved oxygen. Dissolved oxygen is vital for the existence of aquatic life. If the amount is too high or too low, it can be fatal to the aquatic life within the stream. Oxygen enters a water body when the air is mixed with the water, or when aquatic plants release oxygen through photosynthesis. The test showed that the parts per million of oxygen dissolved in water, and the preferred range is 5 to 11 parts per million. Our three locations were acceptable to perfect, aside from the 204 location in March, which had a dissolved oxygen level of 12 parts per million. And lastly, alkalinity. It's a measure of a water body's ability to protect itself from changes in pH. So it's often referred to as the water's buffering capacity. High alkalinity creates a resistance to changes in pH, and water with a low alkalinity is susceptible to changes in pH. The range for that is 0 to 50 milligrams per liter is considered a low alkalinity. 51 to 150 milligrams per liter is a moderate alkalinity, and anything above 151 is considered high. Our results showed moderate alkalinity levels all year in all of the locations, except the 204 in October, which was at 160 milligrams per liter. So the conclusion was that, of the existing research, is that none of the locations are acidic, hardness is higher than desired, especially in Ladiga and 204, and the dissolved oxygen is very good except for 204 in March. And lastly, the alkalinity is moderate to good except for the Alabama 204 location in October. Are there any questions?